Welcome to the deep dive. Today, we are focusing on something a little different. Not software, not the latest model, but the literal infrastructure of the future.
Right. The gears, the cooling, the silicon that makes this whole AI world actually turn.
Exactly. And we're diving deep into a technology release that the analysis we've been studying calls a reset of assumptions. This is something much bigger than just a standard upgrade.
That's the key thing to grasp here. For the last, 4 years, the headline story for AI has just been pure capability.
Look how smart this is.
Look what it can generate.
Yeah.
But the story for 2026 is, well, it's pivoting really fast to affordability and operational scale.
Okay.
And the sources frame this whole conversation around Nvidia's new Rubin platform. They're explicitly calling this shift the Rubin moment, a fundamental compute reset.
A compute reset. So our mission today is to look past the usual marketing. We don't really care about a few more teraflops here and there. We want to unpack the deeper story, the economics, the architecture, and what this actually means for you, for your organization. What happens when AI stops being a cool, expensive experiment and becomes, a utility?
And that's the vital context. The whole boom has been fueled by capability just rising so much faster than affordability.
Right.
Companies love the idea of running these massive models, but the reality is the expense, the power consumption, the sheer complexity has kept AI in a pilot phase for a lot of people.
It's a science project.
It is. But now AI is shifting from being a novelty to a dependency, something you need for core business functions. And when that happens, suddenly the unit economics, they matter more than any abstract benchmark score.
So if you can't afford to run at 247 across millions of customers,
Then you can't build a business on it. Simple as that.
it's the difference between having a super fast sports car and having, say, a whole fleet of cost-effective delivery trucks. You need the trucks for industrial scale.
Precisely. And that's the transition that pushes us right into how Nvidia is changing its own business model.
Okay, so that's where we start. Their strategy. It's clearly moving away from selling, single powerful components.
Oh, absolutely.
It feels much more like platform dependency. It's no longer about selling a GPU. The whole game is platform over component.
Exactly. The analysis shows they're selling a full integrated stack. This isn't just a powerful chip, it's the whole purpose-built system.
So what does a full stack even entail in this context?
We're talking CPUs, GPUs, high-speed interconnects, networking, data processing units, and the software that runs on it. All of it engineered to operate as a single coherent platform. Rubin is being framed very explicitly as an AI supercomputer.
And that framing feels really significant because traditionally an organization buys components and then they integrate them themselves.
Right, they pick a rack from one company, a cooling system from another.
Yeah, and here they're buying a pre-optimized black box.
That's the whole pivot. The sources we look at, they highlight how this stack ensures those massive performance claims are actually achievable because they've gotten rid of the friction points that pop up when you're mixing 5 different vendors.
And this isn't just some abstract roadmap hype, right? This is becoming real.
It's becoming very real. We're seeing reports from CES 2026 where the Nvidia Rubin NVL72 platform was stated to be in production already. Availability is expected in the second half of 26.
So it's not a whiteboard sketch anymore. It's an operational reality that we need to start planning for now.
And that operational reality points to the biggest architectural implication. Rubin is designed to shift AI from being, as the sources call it, a pilot in the cloud.
A small, bespoke project.
Yeah, to looking like true industrial infrastructure. Think moving from a boutique coding shop to a fully automated manufacturing plant.
It just sets the new standard for everyone.
It does. It basically says the time for tinkering is over. The time for scaling is now.
Okay, so let's unpack that. Because that industrial pivot brings us to what I think is the most disruptive part of this whole analysis. The main reason this is a Rubin moment is this fundamental shift in how we measure success. We're moving away from just raw speed, benchmarks and flops, to measuring cost per token.
This is absolutely crucial for any organization buying and deploying AI. And let's be clear about what we mean by tokens.
Right.
The source material defines them as the basic unit cost of your output. Organizations, they aren't buying intelligence, they're buying outputs.
They're buying automated customer interactions, generated code, strategic decisions.
Summaries, tasks completed by agents, all of it. They're buying a business output.
So the CIO signing the check doesn't care about chip speed. They care about how many automated decisions they get for that money.
Exactly. And the analysis suggests that the cost of producing that token is the only metric that really matters at scale. If a query cost you $1 in 2025 and now it costs you a dime,
You can afford to run 10 times as many. That completely changes your budget. It changes what's even possible.
and the claims here are, well, they're enormous. The internal metrics cited by the sources say Rubin can deliver up to 10x lower cost per token compared to the Blackwell platform.
10 times. I mean, that's not iterative. That's a disruptive economic compression.
It is. And think about the budgeting implications. Before the CFO says, okay, we can afford AI for these few high-value tasks, if the cost drops by 90%, AI use cases just flood the zone.
Suddenly, you can have AI summarize every single customer service call, not just some of them.
Or deploy thousands of reasoning agents instead of hundreds.
Yeah.
But what's actually making this 10x jump possible, it isn't just brute force.
Yeah.
It's more nuanced. The breakthrough is tied to very specific, computationally heavy workloads. Things like massive mixture of experts, inference, and advanced reasoning.
Okay, mixture of experts. Can you simplify that for us?
Sure. So instead of having one monolithic, super genius model that tries to answer every single question,
Right.
it's like having 10 specialized experts. The model dynamically calls on the one or two experts it needs for that specific query.
Sounds more efficient, but also really complex to manage.
It is, which is why it's historically been so expensive.
Mm-hmm.
But when the economic barrier for these demanding tasks just drops by a factor of 10, that's what drives operational viability.
Yeah.
The cost per token metric is the bridge from a theoretical performance gain to a practical mass market utility.
And that economic shift is only possible because of the underlying architecture. This is the next reason for the moment. The analysis calls it extreme co-design.
Yes.
It sounds like they're just abandoning the modular playbook that's defined data centers for decades.
They are absolutely burning that playbook. Extreme co-design means they're designing the rack, the chips, the networking, even the cooling, all as one integrated closed system.
So they're moving away from treating those as modular parts you could just swap out.
Completely. And look, there's a strategic risk there for the customer, but it's also the performance payoff. By co-designing, they can guarantee performance that's just. It's impossible in a mix-and-match environment. They can push their proprietary interconnect, NVLink, to speeds a standard system could never manage.
So the result is that Rubin is more than a faster chip. It's a physical blueprint for how AI data centers will be built and operated from now on.
It dictates the entire physical environment.
Yeah.
And that's by necessity. The analysis shows that this level of integration is essential because the workloads themselves are changing.
What's changing about them? What are we asking AI to do in 2026 that's so different?
The focus is shifting heavily towards agentic AI systems.
Which means
It's not just a model generating text anymore. It's an AI initiating action, orchestrating complex workflows, maintaining a persistent state. Think of it moving from answering a quick question to running a continuous business process.
like managing a supply chain
Well,
or handling a customer retention campaign.
exactly. These are long-running inference tasks, always-on reasoning. And that requires bulletproof reliability that older modular systems would just struggle with.
So the extreme co-design, the rack scale integration, it's all in service of supporting these continuous agent operations.
That's it, and the final industrial details confirm it. The NVL72 system is rack scale. It uses liquid cooling as a primary feature, not some add-on. The whole emphasis is on maximum throughput, minimal friction. It's making AI deployment factory-like.
They're solving industrial friction at the architectural layer.
That is the perfect summary. They're anticipating the operational headache and solving it before you even sign the PO.
Okay, so let's zoom out. What does this all mean for the people who actually have to use this stuff? Let's start with business leaders.
For business leaders, the message is, I think, simple but profound. Your AI strategy is your infrastructure strategy now. You can't separate them.
Because if the cost per token drops by 10x,
Previously uneconomical use cases suddenly become not just viable, but necessary. You have to accelerate adoption across the board, or you risk a competitor just blowing past you by leveraging this new affordability.
that sounds like a terrifyingly fast adoption curve.
It is. And the analysis warns that this acceleration also massively increases your exposure, your security, your governance, your operational oversight. It all has to accelerate at the same pace to keep up.
And this is where it gets really interesting, I think, for the people who actually have to sign the checks, the CIOs and procurement teams.
Right.
This integrated stack sounds like a dream, but what's the risk they're buying into?
The primary risk is what we touched on earlier. Dependency.
Yeah.
Vendor lock-in.
It's the Apple ecosystem problem, but for your data center.
Exactly. You buy the integrated phone, you're committed to their charger, their app store, their repair process. The buying conversation shifts from just acquiring tool features to purchasing platform dependency. It's powerful, but it ties your operational destiny to one vendor.
So even with a 10x cost saving, the procurement conversation gets much, much more complex.
Absolutely. The critical factors for procurement teams change. They have to focus on the contracts, on auditability, on visibility into model changes, and this is the most important one, workload portability.
How hard will it be to move my mission-critical system if 3 years from now, someone else offers a better platform?
And that difficulty is part of the cost of admission to this Rubin moment.
Finally, let's look at the broader implications. For society, cheaper AI means more AI everywhere, more synthetic content, more automated decisions.
And more agentic action. It amplifies the benefits and the risks at the same time, and at a really dramatic pace.
So there's a paradox here.
There is. The deep dive identifies it clearly. If the unit cost of AI collapses, the sheer volume of AI activity grows enormously, which means the potential cost of mistakes, bad automated decisions, flawed agents, mass-produced misinformation, it also rises dramatically.
Just because of the sheer scale, it's the scale of the error, not the severity of an individual one.
Yeah, exactly. One bad decision at industrial scale is a catastrophe, in a way that one bad decision in a pilot environment just isn't. So to reiterate our core conclusion here, calling this the Rubin moment isn't just marketing hype. It's about recognizing a potential reset in AI economics and infrastructure design.
It's a bet.
It's a huge bet. Nvidia is betting that the next wave of AI is defined by industrial-scale deployment, where reliability and cost per output are the only things that matter.
And that's really the final takeaway for you. If Rubin delivers on these claims, the 10x cost reduction, the industrial readiness 2026 is going to feel like a hinge year. Not because AI got that much smarter, but because it got exponentially cheaper and easier to run at scale.
When that economic and architectural barrier gets removed, everything downstream, business, government, society, it all accelerates at a, frankly, dangerous pace.
So let's end with a provocative thought for you to take away.
Considering that inevitable collapse in unit cost and the explosion in the volume of automated actions that will follow, how quickly must our governance, our regulations, and our oversight evolve to handle the sheer, unprecedented volume of AI-driven decisions that are about to happen now that the operational cost constraint is being removed entirely? That's the race we're truly starting in the second half of 2026.